Hi, have you ever wondered what's actually going on under the hood in ChatGPT? Today we're going to look at the technologies behind ChatGPT, and we're going to start with something more familiar: autocorrect. Autocorrect begins with something basic: frequency. In this context, it's how often certain words appear together in real text. If I type the word thank, Google will suggest thank you as a top search because thank you is the most common phrase with thank. Because of this, the system learns a conditional probability, which just means the probability of one word given another word coming right before it. So we might estimate the probability of you given thank as around 0.9, meaning there's a 90% chance you is the intended next word after thank. Autocorrect simply picks the word with the highest conditional probability, and it looks at the history of sentences. But let's say we want to make new sentences that have never been made before. How do we do that? To do that, we scale this idea into a Markov chain by representing word transitions as a graph. Here, each node in the graph is a word, and a directed edge from word A to word B means that B has appeared after A. The weight on each edge records how frequently that transition occurs. This might look a little complicated, but it's just a bunch of conditional probabilities next to each other. This lets us generate sentences by sampling the next word purely from these transitional probabilities. So from this graph, you could get the sentence, today I went climbing, and I wonder if I will feel sore tomorrow, but you could also get just today I went climbing or today I will wonder. The Markov assumption that the next word depends only on the last word or two is extremely limiting because real language carries meaning across entire sentences, not just one-step transitions. This is where neural networks come in. Each neuron in a neural network acts as a small processing unit where it takes inputs from the previous layer, multiplies by weights, sums them with a bias, which is just some mathematical shift, and then passes the results to an activation function to produce an output. This happens for many layers, and there are many neurons per layer. This matters because instead of modeling languages as fixed transitional probabilities between words, neural networks learn a continuous representation of context. The model does not ask what usually follows this word, but instead, given everything I've seen so far, what word best fits next. Through this process, the network can learn complex patterns, word shapes, grammatical structure, and even semantic meaning. So how does this connect back to ChatGPT? To make neural networks work on language, we first need to turn words into numbers. This is where vector embeddings come in. Instead of representing each word as a discrete symbol, we represent each word as a vector in a high-dimensional space. Words with similar meanings end up closer together in this vector space. When you type a prompt, your text is broken into tokens, and each token is converted into its own embedding vector. These vectors are passed through many layers of a neural network where they are repeatedly, continuously updated to reflect the meaning of the entire prompt, not just individual words. At the final layer, the network uses these updated vectors to compute a probability distribution over the next possible token. The token with the highest probability is selected, added to the input, and then the entire process repeats. One word at a time, ChatGPT builds a response. Each new word slightly changes the vector representation of the context, which in turn changes what the model predicts next. Now, let's try our toy version of ChatGPT. So I have a quick Python script with a few vocabulary words. This demo takes your input text, I am happy, converts each word into a vector embedding, and combines those vectors into a single context representation. That context vector is passed through several neural network layers where it is transformed using learned weights and nonlinearities. The final output is a probability distribution over possible next words, and the most likely one is selected as the model's response. In this case, it is climbing, so it makes the sentence, I am happy climbing. ChatGPT just does this on a much larger scale with much more vocabulary words, layers in the neural network, and neurons. Thanks for listening.